To Strongyear's Clubhouse. I am your host Dragonborn, and this is my new video series. I'm calling it My Mind to Your Mind. And basically what I do is I talk about things that are either related to the normal episodes I make, but I couldn't get into, or are just completely different from the episodes. In my first episode and fourth episode, I went into things that have to do with the weird rules of quantum mechanics, and I want to expand on the three other principles. So the three other principles are the particle wave duality, quantum tunneling, and quantum entanglement. So let's start with the first one, quantum tunneling. So the first one, particle wave duality. Basically, it states that a particle can be both a wave and a particle at the same time. Well, to be more specific, a particle, a quantum mechanical object, because this doesn't just have to do with particles. It can do with macro scale objects too. But whatever the object is, whether it's a solid, whether it's a state, whether it's a particle, what we classify as a particle, something solid, or a wave, basically this states that it could be both a particle and a wave at the same time. Although it's more like it's not, and the wave is described as a probability wave, where it still acts like a wave, where the basic idea is whenever you look for something, the probability wave is how likely am I to find this electron if I look for it. So, for instance, you might have heard the double slit experiment. That's a good example of particle wave duality. Doing tests with things that are normally considered particles and showing there are waves, and there's the probability wave theory describes that observation. So the probability wave idea states that the actual wave, it's not that it's multiple electrons, it's not that pieces of the electron smeared over a large distance. It's just a probability wave that it's a probability that if you look, and it's a probability that you'll find the electron or the particle or quantum object in question there. That's the particle wave duality. Quantum tunneling is a bit easier to explain. Imagine for quantum tunneling, it basically states that that a quantum object can jump to the other side of a wall without having to travel the space in between. It's like walking up to a wall and then instantly teleporting to the other side. Again, it's still based on the Heisenberg uncertainty principle, where it's a very small chance that it will happen, but the chance is there, and indeed it does happen. Where, say this is a wall, and then there's a particle trying to go through it. Classical mechanics says the particle can't go through it, and even in quantum mechanics, the most likely scenario is, and this happens to most particles, it will just hit and bounce off. But there's still a small chance, again, it does happen, where when the particle hits, it teleports to the other side and continues on, tunneling through the object. There's also a chance it could be inside the object too. So, yeah, that's quantum tunneling. Now, for the last part, quantum entanglement. This is currently one of the most baffling principles of quantum mechanics that we know of. It's been compared to the closest thing to real life as magic, although it's not really. There's a theory I'll get into that perfectly describes it, but the entanglement says that if you entangle two particles, the state of entanglement means that if you know the state of one, you can tell the state of the other. So, if, let's say, these are fuzzy quantum objects that are just sitting here, they're in multiple states at once, quantum superposition, until you look, and I look at this, just this, and then I see that it's pointing upright, I know that the other particle here, or quantum object, if it's entangled, I will know that this is facing downward. Now, one of the reasons why this is so baffling is because the information, and by the way, information is the state of the particle is the state of the material, or of the particle. That's quantum information. So the quantum information from this traveled to this without traveling into space in between, and it has been, and because we know entanglement is real, it's theoretical, but it's still possible. And indeed, we have, if I'm correct, we have gotten measurements of this, that it actually can actually transmit data faster than the speed of light. Now, one theory about this and how it can do this, because if any of you have read through a general relativity book, you know Einstein said that nothing could travel faster than the speed of light. And believe me, he desperately tried to find something that traveled faster than the speed of light. But he didn't find anything, so that's the conclusion he came up with. Will it stay there forever? No, but I'm not going to go into that. So, let's say speed of light is the fastest speed in the universe. How could the quantum information, or the state of a particle, instantly affect the state of the other particle without traveling to space in between? That's one of the things that was troubling physicists now. But there's a theory, and this kind of explains it. And the idea is that when the two particles entangle, it's actually like an imperfection in space-time. So if you imagine looking at something like this, it seems that it's perfectly smooth, perfectly fine. But if you look down deep enough to start getting close to the nanoscales, you can see small imperfections in this. And it's thought that entanglement works this way. Or when you entangle two particles, they're really taking advantage of an imperfection in the very fabric of reality, where it's kind of like they are actually in the same place, but not. It's like the place they're in is connected through this imperfection in space, to where the information, it's kind of like they're both affected by the same thing in the same space. Sorry, a thing just popped up on my screen. Anyway, where it actually does describe it pretty well. So that'll be it for this episode of My Mind to Your Mind. I hope you like this kind of content. That you like this type of style. If you do like it, give me a thumbs up and subscribe if you would like. I have other videos where I answer questions sort of like this, but in a different style. I hope you enjoyed, and let the science be with you.